This is Dr. P. Srilatha, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Hyderabad. In this session, I am going to discuss about test of hypothesis for difference of means. What is test of hypothesis for difference of means? So, here we are having two samples. Difference of means means double means. Double means. We are checking for double means. Okay. So, let x1 bar is the mean of the sample. X1 bar is the mean of the sample and the sample size is n1. From the population, mean mu1 and standard deviation is sigma 1. So like that, x2 bar is the mean of the sample and the sample size is n2. From the population, mean mu2 and standard deviation is sigma 2. So then test statistic is z equal to x1 bar minus x2 bar divided by under root of sigma square by n1 plus sigma square by n2. So here we are taking two samples. So like that we can identify. Okay. So here we have two samples. Two samples are there. Okay. So those two samples are n1, n2. Okay. So those means are x1 bar and x2 bar. And the standard deviations will be s1, s2. Our variances are s1 square, s2 square, and standard deviations are s1, s2. So, and in what is the population here? The population is actually capital N1, N2, and population mean is denoted with mu1, mu2 if we have two populations. Okay, so population is always one only, and in that standard deviations are sigma 1 and sigma 2. Okay, so this is the formula for test of hypothesis for difference of means z equal to x1 bar minus x2 bar divided by under root of sigma square by n1 plus sigma square by n2. So this is for two means or for two samples. So note, if sigma 1 and sigma 2 are unknown, so then we can use S1 and S2. So sometimes they are not, they will not give the population standard deviations. At that time we have to take sample standard deviations. Sometimes they will give like that. Okay. So at that time we have to use this formula. So that is z equal to x1 bar minus x2 bar divided by under root of s1 square by n1 plus s2 square by n2. And one more note is there. So that is if samples are drawn from the same population. If the samples are drawn from the same population, so if the different populations are there like N1, N2, these are the different populations, in that sigma 1 and sigma 2 will occur. But in the same population means here the sample will, the population will be n. So in that we have only one standard deviation will be there at that time. That means sigma 1 equal to sigma 2 equal to sigma, that is equal to x1 bar minus x2 bar divided by sigma square by n1 plus sigma square by n2, or we can write sigma x1 bar minus x2 bar divided by sigma into 1 by n1 and the root of 1 by n1 plus 1 by n2. So this is the formula. Okay, so this is the formula for test of hypothesis for difference of means. So this is also one method for large samples. Okay, this is our second method to solve different test of hypothesis for large samples. Okay, so first problem. So there are okay. So let us consider first problem. The mean of the two large samples of sizes 1000 and 2000 are 67.5 and 68. Can the samples regarded as drawn from the same population of standard deviation 2.5 at 5% level of significance? Okay, the sample of two large samples of sizes 1000 and here they have given that sample sizes, that means two samples, no, so that's why we have to consider that is n1 and n2. Sample sizes are 2 here. So first sample size is n1 equal to 1000 and second sample size is n2 equal to 2000. And starting they have given that, in the starting they have given that the means of the sentence starts with means, right? So the means of the large samples are 67.5 and 68. So means of the samples, that means the means of the sample means are denoted with x1 bar, and here we have two samples, no? So that's why we are writing x1 bar and x2 bar. Sample mean is denoted with actually x bar, sample mean. So sample mean is denoted with x bar, but here we are having two samples now, so that's why we have to take x1 bar equal to 67 point and this one, and x2 bar equal to 68. So here what is, whether it is large sample or not, okay? So here n1 is 1000, that means n is greater than or equal to 30. What is large sample? Large sample is nothing but n is, if n is greater than or equal to 30, then we can say that that is large sample. So here we are having n greater than or equal to 30 only. So this is also n greater than or equal to 30. So that's why these two are large samples. Okay, so n1 and n2. n1 is 1000 and n2 is 2000. And the means of the samples are x1 bar equal to 67.5 and 68. Can the samples be regarded as drawn from the same population of standard deviation is 2.5. So continuation question, observe the question carefully. So can the samples regarded as drawn from the same population? So, and the continuation question is standard deviation is 2.5. Okay, so here I am taking, here they have given that only one sigma. Okay, so that is population standard deviation. Population standard deviation is denoted with sigma. The sigma value is 2.5. Okay, sigma value is 2.5. So at 5% level of significance, at 5% level of significance. So 5% level of significance means that is 0.05. So here they have given that n1 is 1000 and n2 is 2000 and x1 bar is 67.5 and x2 bar is 68. And the sigma, here they have given that only one standard deviation. So that is sigma equal to 2.5 and alpha is 5%, that is nothing but 0.05. Okay. So if they have given only one sigma, then we have to use z equal to sigma 1 bar, x1 bar minus x2 bar divided by sigma into under root of 1 by n1 plus 1 by n2. Or you can use z equal to x1 bar minus x2 bar divided by sigma square by n1 under root of sigma square by n1 plus plus sigma square by n2. So that is the formula. So these values are fit to z equal to x1 bar minus x2 bar divided by sigma into under root of 1 by n1 plus 1 by n2. Okay, so but here we have a procedure, right? So for large sample tests or small samples tests, we have procedure. So what is that procedure? So first one is a null hypothesis. We have to set up the null hypothesis. And second one is alternative hypothesis. Third one is level of significance. So fourth one is test statistics. Okay, so that is Z, and the fifth one is conclusion. So in this case, in the conclusion, if mod Z greater than Z alpha, we reject the null hypothesis. If modulus of Z less than Z alpha, we accept the null hypothesis. So for the entire question, here we are having two large samples, right? So two large samples, two samples. For two samples, we have to set up the null hypothesis is x1 bar equal to x2 bar. Two samples are there. Okay, so null hypothesis. So null hypothesis is nothing but our given statement. Okay, so given statement here I am writing is so x1 bar equal to x2 bar. Okay, so the two samples, this is nothing but two samples are came from the same population. Okay, so check whether it is whether the two samples are came from the same population or not. Okay, so that's why here there is no difference between, there is no difference in the statement. Okay, so an alternative hypothesis is nothing but there is a difference in the statement. Okay, so there is no difference in the statement, so that is null hypothesis. Okay, alternative hypothesis opposite to the null hypothesis. So that means if you take there is no difference in the null hypothesis, there is no difference in the statement, means here we need to take there is a difference in the statement. Okay, so if here I am taking x1 bar equal to x2 bar, so alternative hypothesis is nothing but opposite to the null hypothesis, so that's why x1 bar not equal to x2 bar, so that means that is two-tailed test. So one thing here, remember, in two-tailed test we have to take in two samples we have to take two-tailed test. Okay, directly you can write that is not equal to. Okay, so next one is level of significance. So level of significance, they have given that alpha equal to 0.05, alpha equal to 0.05. So that means what is alpha value here? Alpha value is 0.05, or alpha they have given that 5%. So alpha value 5% in two-tailed test. Alpha value 0.05 in two-tailed test is Z alpha equal to 1.96. Z alpha equal to 1.96. Already we have taken from the table in the previous session. Okay. So next, test statistic. Test statistic is here we need to write the formula. So actually the formula is z equal to x1 bar minus x2 bar divided by under root of x1 bar or x1 square by n1 plus x2 square by n2. But here we are having only one sigma. So that's why here I am writing x1 bar minus x2 bar divided by sigma into under root of 1 by n1 plus 1 by n2. Otherwise x1 bar. So here this is nothing but x1 sigma 1 equal to sigma 2, that is equal to sigma. Okay, so otherwise in that case also you can write. Okay, so but here, so better to write, we have formula, no? So that's why z equal to x1 bar minus x2 bar divided by sigma into and a root of 1 by n1 plus 1 by n2. So here x1 bar is already we know that x1 bar is 67.5 and x2 bar is 68. So this is 67.5 minus 68 divided by what is sigma value? Sigma value is 2.5. Sigma value is here 2.5 into under root of 1 by n1, 1 by 1000 plus 1 by 2000 into value. Okay, so if you simplify this one, we will get minus 5.16. But we need mod z, right? But we need mod z. So here the mod z, so we have to convert the answer into positive. So that's why that will be 5.16. Okay, so that is 5 mod z equal to 5.16. Okay, so now take, so if in the conclusion, now find what is whether it is less than or greater than. So mod z is 5.16. So we know that mod z is 5.16, and what about z alpha? We have written in the third step. What is that third step? Level of significance. Alpha equal to 0.05 in two-tailed test is z alpha equal to 1.96. So that is a tabulated value. So this is a table value or tabulated value. So tabulated value. So this is calculated. We have calculated this value now by using formula. So that's why this is calculated value. So here the calculated value is greater than tabulated value because 5.16 is greater than 1.96. 5.16 is greater than 1.96. That's why calculated value is greater than tabulated value. So that means modulus of z greater than z alpha. Mod z is greater than z alpha. Then we reject the null hypothesis. That means the given statement is wrong statement. What we have taken from the equation is that is wrong statement. The samples are samples can be regarded as drawn from the same population. So what we are checking is the samples are not from the same population. So those are came from the different populations. Okay. So next question is the next question is mean of wheat from a district A was 210 pounds with standard deviation is 10 pounds per acre from a sample of 100 plots. So in another district the mean was 220 pounds with standard deviation 12 pounds from a sample of 150 plots. Assuming that the standard deviation of entire state was 11 pounds, test whether there is any significance difference between means. There is any significance difference between two means. So now we need to check whether there is any significance between difference between means. Okay, so for that, here the mean of wheat from the district A was 210. Mean. So mean of the sample. The mean of the sample, they have given that x1 bar equal to 210. So given x1 bar equal to 210. And then that continuation sentence is sample standard deviation. So sample standard deviation is denoted with S1. So here S1 equal to 10. S1 equal to 10 per acre from a sample of means sample size of. So what is the sample size? The sample size is denoted with n. So but here we are having 2, no, so that's why we are taking n1. So n1 equal to 100. So check whether it is a large sample or not. Yes, this is a large sample. Large sample. Why we are saying that is large sample? We know that if n is greater than or equal to 30, then we can say that that is large sample. So here n1 equal to 1000. That's why n1 equal to 100. That's why that is a large sample. Okay. So in another district, the mean means mean of the sample was, that is x2 bar equal to, so x2 bar equal to 220 pounds with standard deviation. That means sample standard deviation. We know that sample standard deviation is denoted with S. So that's why we can write, already we have one more sample standard deviation. That's why we need to write, that is S2 value. So S2 equal to 12. Okay. So from a sample of 150 plots, sample of means sample size of. Okay. So we know that sample size is denoted with N2. So N2 equal to 150. Okay, so assuming that this standard deviation of the entire state was 11 pounds, that means standard deviation of entire state means that is nothing but population. Okay, so population standard deviation, entire state means total state, that means that is a huge amount. So that's why that is collection of objects. Okay, so these two collection of objects, right? So these are the objects. Collection of objects means population. The entire state means here population. So that's why this is population standard deviation. That is sigma. Population standard deviation is denoted with sigma. So they have given that sigma equal to 11. So what about the level of significance? They have not given level of significance. That's why here I am assuming that level of significance is 5%. Okay, so here n equal to 100 and n1 equal to 100, n2 equal to 150, x1 bar equal to 210 and x2 bar equal to 220, s1 equal to 10, s2 equal to 12, and they have also given that sigma value and alpha value. Here I am assuming. Okay, so assuming that alpha equal to 5%, that means the alpha is 0.05. Okay, so according to these values, what is the formula? Which formula is fit to these values? Okay, so these are two samples, right? So that's why we can use test of hypothesis. These are here we have two means, right? So that's why we can use test of hypothesis for difference of means or double means. Okay, so that is z equal to x1 bar minus x2 bar divided by and a root of s1 square by n1 plus s2 square by n2, and also they have given that sigma value. So that's why we can take x1 bar minus x2 bar divided by sigma into 1 by n1 plus 1 by n2. So there are two possibilities. Are there to find the solution of this problem. But here I am using only this formula. Okay, only this formula. That means here I am not using sigma value. Okay, so our first step is null hypothesis. Null hypothesis is denoted with H naught. H naught equal to, H naught is nothing but here I am taking, there is no difference between the means. Okay, so test the significance. What is our question? Test whether there is any significance difference between the means. Here I am taking there is no significance difference between the means. So alternative hypothesis. So what is alternative hypothesis? So alternative hypothesis is nothing but opposite to the null hypothesis. Okay, so here I am taking the alternative hypothesis, that means x1 bar not equal to x2 bar. That means there is a difference, there is a difference between these two means. Here I am taking there is a difference between these two means. So in first case there is no difference between the two means, that is x1 bar equal to x2 bar. So here there is a significance, a difference between these two means, that means x1 bar not equal to x2 bar. Okay, so next level of significance. So understand that so alternative hypothesis is opposite to the null hypothesis. Okay, so if you write alternative hypothesis is x1 bar not equal to x2 bar, that means that is two tailed test. Okay, so in double mean or double proportions we have to take that is two tail test, because here we are having two samples. Okay, so that's why we need to take two tail test. Okay, so next one is step 3, level of significance. In level of significance they have not given alpha value, so that's why we are assuming that alpha value is 5%, that means alpha is 0.05. Okay, so if alpha is 0.05 in two tail test, then z alpha is 1.96. We have to take from the table. So we have to take 1.96 from the table. So that means that is tabulated value. So tabulated value, because we are taking this value from the table. Okay, so z alpha value is 1.96, where alpha is 0.05 in two tail test. Okay, so next, test statistic. So here I am using test statistic is z equal to x1 bar minus x2 bar divided by under root of s1 square by n1 plus s2 square by n2. So x1 bar, already we know that x1 bar is 210, x1 bar is 210 and x2 bar is 220. x1 bar is 210 and x2 bar is 220. x1 bar minus x2 bar, 220 minus, so 210 minus 220 divided by under root of s1 square. So what is the value of s1 square? So s is 10. Sorry, s1 is 10. So but we need to write s1 square. That's why that is 10 whole square. Okay, so s1 square. So s1 is 10. So that's why s1 square means that is 10 whole square. Like that, s2 value. So what is s2 value? s2 value is 12. So s2 value is 12. So s2 whole square means 10 whole square. Okay, so s1 square by n1. So n1 is 100 and n2 is 150. So s1 square by n1. So this is s1 square by n1. So that means 10 square by 100 plus s2 square by n2. That is 12 whole square by n2 value is 150. Okay, so simplified this value we will get z equal to 1.74, but we need mod z, right? So that's why mod z equal to also same, no? So that is 7.14. Okay, so conclusion. So conclusion means here we have to write like this. Okay, so what is mod z value? Mod z value is 7.14. So what is z alpha value? So z alpha value is 1.96. Okay, z alpha value is 1.96. Is 7.14 is greater than 1.96 or not? Or less than 1.96? Yes, so 7.14 is always greater than 1.96. That means mod z is greater than, so this value is this one and this value is this one, right? So that's why mod z is greater than z alpha according to this one. Okay, so according to this one, so mod z is greater than z alpha. So if mod z is greater than z alpha, then we reject the null hypothesis. So we reject the null hypothesis. So we reject the null hypothesis means, so we reject our statement. So that means the given statement is wrong statement. So what is our given statement? We are assuming that there is no difference between significance. So there is no difference. There is no significance difference between means. Here I am taking there is no significance difference between means. Okay, so that is wrong statement. That means here there is a significance difference between means. So what is the answer here? There is a significance difference between the means. So next problem. So our next problem is a sample of students. Yes, I am closing the session. So here our answer is there is there is a difference between there is a significance difference between means. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.